Hello and welcome back to another video. This time we will discuss exponential functions, integral of exponential functions. So there are two formulas that we will consider in this topic. First is the integral of e raised to u differential u and the integral of a raised to u differential u. So by now you should already know that you will consider un differential u, and you should always establish the relationship in the integrand that you are solving. So if you have already established un differential u, the relationship of that in the integrand that you are solving, then you can apply these two formulas. So this is very easy to remember. First is e raised to u plus c, so almost the same as your integrand, and the second one is a raised to u, so the difference is you will divide ln a and then the natural logarithm of a, and then add the arbitrary constant c. So first example, so let's say the integral of e raised to negative 3x differential x. So first, choose the appropriate u. The appropriate u is negative 3x, and the differential of that is negative 3 differential x. So it satisfies our formula of e raised to u du. You have here e raised to negative 3x. Your differential is negative 3 differential x. So all elements are present except for the negative 3, which will be balanced out by use of the balancing factor, the reciprocal of the numerical coefficient that we have introduced because of getting the differential. So you already know that. Let's just apply the formula here. So we have negative 1/3 as our balancing factor, and then write e raised to u plus c. So e raised to negative 3x plus c. So as simple as that. So let's try number 2, the integral of 10 raised to negative 4x differential x. So first, choose an appropriate u. So that is negative 4x. The differential is negative 4 differential x. Right here 10 raised to negative 4x as your a raised to u, and then the differential is negative 4 differential x, balancing factor of negative 1/4. So apply the formula, write the balancing factor first, and then write a raised to u 10 raised to negative 4x all over ln a, so that is the natural logarithm of 10, and then add plus c. Okay, so you can rewrite this as negative 10 raised to negative 4x, and then 4 times the natural logarithm of 10 plus c. Let's go to our third example, number 3. So let's say we have the integral of e raised to x, quantity e raised to x plus 1 squared over e raised to x, and then differential x. So here, you will not directly apply the formulas that we have here, because you cannot establish a correct relationship between whatever you will choose and the differential. So the first thing that you will do here is to simplify. No, we need to expand this first and then divide e raised to x. So if we expand this, let's review. We have a plus b squared, so that is a squared plus 2ab plus b squared. So if we apply e raised to x plus 1 squared, we will have e raised to 2x plus 2e raised to x plus 1. Okay? And then we will divide e raised to x. So it's like e raised to 2x over e raised to x plus 2e raised to x over e raised to x plus 1 over e raised to x. And then we have here the differential x. So simplify. So e raised to x over e raised to 2x. So that's you simply subtract the exponent. So 2x minus x will be left. Here, e raised to x is cancelled out because e raised to x divided by e raised to x is 1. And then you can simplify this as e raised to negative x. Okay? So you will have three integrals. So one is e raised to x differential x plus 2 differential x, integral of differential x, plus the integral of e raised to negative x differential x. So here, this is very simple. This is e raised to x plus 2x, and then you can just imagine that we have here u as negative x, so we'll have a balancing factor of negative 1, so plus minus e raised to negative x plus c. Let's just rewrite this to be e raised to x minus e raised to negative x plus 2x plus c. Okay, so relate lang natin so that the order would look better. So next, and this will be our last example for this video, e raised to tangent theta over cosine theta differential theta. So the integral of e raised to tangent theta differential theta all over cosine theta. This should be cosine squared theta. So let's just correct the given. Okay, so the appropriate u there would be tangent theta, and the differential of tangent is of course secant squared theta differential theta. And as you can see, wala dito yung you cannot find secant squared theta, but we have to remember that secant squared theta is equal to 1 over cosine square. So, or 1 over secant is equal to 1 over cosine. So therefore, secant squared theta is equal to 1 over cosine squared. So we can replace the 1 over cosine square here by secant squared theta. So we have e raised to tangent theta as your e raised to u, and then we have secant squared theta differential theta as our differential u. So the relationship is now satisfied. We can now simply answer e raised to u plus c. So e raised to tangent theta plus c as our final answer. So I hope you learned something from this video. We will have more complicated problems during our synchronous discussion. Thank you for watching.